Hello, this is Dave from Dimensional Consulting. Today's video will discuss Figure 7-27 from the ASME Y14.5 2018 standard. The figure is an explanation of planar common datum features in the free state and in the restrained state. Figure 7-27 looks something like what we see here. This figure shows a rather unusual way of handling restrained versus not restrained. Usually, if a part needs to be restrained, we include a general restraint note. Unless otherwise specified, the general restraint note applies to all of the tolerances on the part. If a tolerance needs to be measured in the free state modifier is used for those tolerances. This figure takes a different approach. It specifies that certain tolerances must be measured in the restrained state and leaves all of the other tolerances to be measured in the free state. Let's look first at the profile tolerance of 0.5. Since it has nothing indicated that it should be measured in a restrained state, it defaults to the free state. The tolerance references datum feature A. We see here that in the theoretical world, the true geometric counterpart is a plane that is tangent to datum feature A. Therefore, datum A is also the plane tangent to datum feature A. In the real world, the datum feature simulator is a gauge with a surface that contacts datum feature A. Simulated datum A is the gauge surface that contacts datum feature A. The profile tolerance measurement is made from simulated datum A. Starting from the gauge surface, go up exactly 20, and centered on that exactly 20 above the simulated datum A is the 5 wide profile tolerance zone. The profiled surface must fit within that 5 wide tolerance zone. All of this takes place in the free state. Now consider the profile tolerance of 0.8 and the profile tolerance of 2. Each of these has a local note underneath them that says C note. The note is a restraint note. Therefore, each of these profile tolerances must be measured when the part is restrained, as indicated in the restraint note. In the theoretical world, at A, the true geometric counterpart is a plane that is tangent to datum feature A. Therefore, datum A is also the plane tangent to datum feature A. In the real world, the datum feature simulator is a gauge with a surface that contacts datum feature A. Simulated datum A is the gauge surface that contacts datum feature A. In the theoretical world, the true geometric counterpart at B is a plane that is tangent to datum feature B. Therefore, datum B is also the plane tangent to datum feature B. In the real world, the datum feature simulator at B is a gauge with a surface that contacts datum feature B. Simulated datum B is that gauge surface that contacts datum feature B. Simulated datum A and simulated datum B are exactly parallel to each other and offset from each other by exactly 20 millimeters. At datum feature A and datum feature B, the profile tolerance zone is two parallel planes, 0.8 apart. In each case, one of those planes is tangent to the gauge surface. The other plane is up into the part. Datum features A and B must fit within those tolerance zones while the part is in the restrained condition. The 2 millimeter profile tolerance zone is perfectly located to the gauge surfaces at A and B. The surface controlled by this profile tolerance must fit within the tolerance zone while the part is in the restrained condition. That's today's video. If you want to see more tips like this, please subscribe. Also, check out the link below to my playlist of explanations of figures in the standard. If there are specific figures or other GD&T issues you would like me to cover, please let me know in the comments. And visit my website at dimensionalconsulting.com.